Hey everybody, welcome to another CS 302 assignment. For this assignment 4, you're going to be essentially creating a Morse code encryption cipher or scrambler cipher program. As you can see, the person right there seems to be rather happy to decode the Morse code. I believe it's because this assignment, you're going to be encrypting and decrypting the original Resident Evil 3 plot, which of course, I mean, the original good Resident Evil games. So, I mean, I think that would make anybody happier than having to have to read the plot of the remake. So, I'm guessing that's the reason why this person in the front, or this gentleman here reading the Morse code, seems to be happy. So, for the assignment, you're going to have to construct a binary search tree class, which is rather not going to be too difficult. I mean, you've gone over this in class, and to insert into a binary search tree and update and find is rather simple. So that's not going to be too complicated. The difficult part would be, if there even is a difficult part, would be the main program where you have to read in the file and then convert each letter into the Morse code, and or be able to take a Morse code file and then convert it into the original text. But that's not too difficult either. But if you want to say there is some difficulty, I would believe that would be the only hard part. Okay, so let's go ahead and just take a quick look at the binary search tree right here in this PDF. So suppose you have these letters in a binary search tree and you want to create sort of a Morse code out of it. And the Morse code will be very simple. It's going to be the directional path that leads you from the root node to any particular node, or sorry, root node to any node in the binary search tree. So for example, if you want to have the letter C, you want its Morse code. Well, from the root, you go left and then right. So then C's code would be LR, the string LR. Capital L, lower capital L, capital R would be the code. For A, it would be LL. For G would be RR. For F would just be R. B would just be L. And then since E is the root node, it would just be S. So it's rather simple to construct this Morse code for each letter. So the first rule is to create a binary search tree from a given set of letters. And then, of course, using the path that leads to that letter, you want to essentially store that path. That's going to be the Morse code of the letter. Okay, let's go ahead and now take a quick look at the actual binary search tree class. Okay, so here's the header file that's going to be provided for you, and of course will be already included in the code grade auto test setup, so you won't have to actually submit the header file. This header file will attach to your bst.cpp file and main.cpp file. So let's take a look at this class BST, which is short for binary search tree. So in our binary search tree class, we're going to have this subclass defined within it, which will be just bin tree node. Now there's no template, so the template will be assigned to the BST class. So T1 is your key type and T2 is your value type. Now since this class bin tree node is defined within BST, you don't have to actually have this class as a template, but it has template types within it because it's defined within the binary BST class. So bin tree node is going to be just a standard, well, it's going to be the node. Each element of your binary search tree will be a bin tree node. So each bin tree node has a T1 key and a T2 value. And of course, you have your left and right pointers. And here are your two constructors that are given to you. So default constructor assigns some default value for the key and value, and it will set the left and right null pointer. Very important to have these two because, of course, you want to make sure that whenever you allocate a new node, you want to ensure that that node's left and right pointers are initialized to null pointer to avoid any possible inconsistencies where perhaps on your Mac it works but doesn't work on Linux. This might help you. Our other constructor, we passed in some key and value, and we're going to assign that object's key and value respectively, and of course set the left and right pointers to both be null pointer. So Pretty basic class bin tree node, and of course it's all public, so it's really a struct in a sense, but we want to make things fancy in CS302 and use a class and have everything be public instead of a struct because, well, classes are just fancier, aren't they? So we'll go with that. Now, in our bin tree node, or sorry, our BST class, we have a bin tree node star root. So we're going to have this root pointer that points to the root of your binary search tree. Okay. Let's go ahead and now look at our public members of our class next. So our default constructor, pretty simple. It will set the root to a null pointer. That's it. The destructor is going to just deallocate the entire binary search tree, and it's going to call the deallocate tree root. So these two members are implemented for you in a header file. Don't worry about implementing these functions in the implementation file. Then we have the insert function. You pass in a key and value, and it's going to, essentially call the overloaded insert function, which of course, again, this function is given to you. You have to implement it, but you would call this function in main. This function would be really a wrapper because you need to internally call the other insert function, pass in a pointer. So this is where we kind of encapsulate that data. By overloading insert, we're able to call insert in main, and then internally we can call another insert function. In that function, you pass in the pointer, and of course that will allow you to recursively traverse your binary search tree. Same for update. You would of course call this in main, and then this is going to call the overloaded update function a private member. Again, this is written for you, so you have to implement this function in the implementation file. Get value, same idea. This is going to return the value field of the node that you passed in. So that's going to be essentially that. Now, I guess I didn't have to make this into a const reference parameter. I might remove this actually after the video, but it doesn't really matter. But I just might, since you might pass in literals into this function, I might not use a const reference parameter. So I might remove this from the header before I upload. So this one again, get value returns the value field of the node that matches this key. Again, we're going to call the overloaded function right here, so it's given to you. Let me go over the private members next, and then of course we can go over the get path function. So deallocate tree is called in the destructor, and deallocate tree is going to just deallocate the entire tree, and you're going to have to do a post order traversal to deallocate the tree. And here's the, I guess, the code in words. You have to deallocate the entire left subtree, then deallocate the entire right subtree, and then deallocate R. Do you see the magic of how you would implement this? The magic of recursion. So I'm not going to say more, but it's really just a post-order traversal. Now, we're not going to really test it out. Somehow CodeGrade's Valgrind check is kind of buggy, so we'll just sort of quickly scan to make sure this function is done, but it's a very simple function. Is just think post-order for a second on that. This insert function right here, I mean, basically, this is just the same insert function given to you in class. I mean, there's not many ways to implement an insert function for binary search trees, so I guess there is source code, of course, in class. Most likely it was covered in class. You can use that source code in class because really there just isn't too many ways to implement insert. Update, this function, you pass in a pointer R, and you just traverse the binary search tree. When you find a matching node with the matching key, this T1 key, you're going to overwrite that node's value field with that second parameter T2. Then get value, well, you pass in a pointer, you traverse recursively down the binary search tree. Once you find a node that matches that parameter T1, return that node's value. That's it. So the insert, update, and get value are going to be all recursive. The get path function, I originally wanted this to be a friend function, but with templates and multiple file linking, this friend function did not want to link for the life of me. So for that reason, I'll make it into a regular member function. So get path, this is going to return. So essentially going back to the beginning of our PDF, the get path function, if I pass in get path, I pass in, like, let's say C, for example, it's going to return back to me a string LR, which is LR is the string that represents the path that leads from the root to C. You pass in the letter, and it will find it, and it will essentially construct this sort of the path. This function, however, is not going to be recursive. So I originally had it as a friend function and didn't have to be recursive because, well, for binary search tree in general, you don't really need recursion per se because you don't really backtrack. You just simply go down one path, left or right. You never turn back because the way you traverse a binary search tree, you only have to go down one path. Whenever you reach a node, you go to the left or go to the right, and that's it. Remember, we only have insert function as recursive because, well, if we're going to, let's say, hypothetically update a binary search tree to handle rotations, returning the pointer and using recursion and backtracking does make the code much more cleaner if we have to rotate our tree. So for that reason, we can just so anyway, the getPath function will be done using a loop, not recursively. But in fact, the loop method might be a little bit easier to actually construct this because you always keep assigning r equals r arrow left or r equals r arrow right. So you can of course create pointers within the function and handle all that. So that's really the quick overview of the binary search tree class. So again, I will provide you a skeleton file which has the bst.cpp. It will have all the functions. You have to fill in the actual function bodies. So now let's go ahead and look at the main and the input-output for the assignment. Okay, so the main content is given to you in the PDF as well as the complete binary search tree description, but I rather just speak my own words rather than read from the PDF. So basically in your file, or sorry, in your main, you're gonna have to read in a few content. You have to read in two file names. The first one will be your letters file. This file will contain letters A through Z in any order, upper and lowercase, characters 0 through 9, then the comma symbol, the period symbol, a space, and a new line. So every character in this every line in this file will contain a character followed by a new line character. So it's new line separated. But you have to use either getLine or get to read these in because, well, you have to read in the blank space. So right here on line 21, the character you have to read in is a new line character, but because every character is new line separated, we have back-to-back new lines in this case. So I guess a get function for your int file would be good because you can do a get to read your character and then do a get to sort of skip or to just read that end of line character so you can now read the next line. Or you can even use ignore function as well. It's up to you how you want to do this. But you have to use get because you need to read in the actual, because sometimes you may have to read in a blank space, either it's a new line or a space has to be read in. So what you're going to do is one by one, read these in, and you want to insert each of these into a binary search tree object. So you will have one binary search tree object that's going to be a character to string map, which means that you want to map the character to its Morse code or its path, which is the Morse code for that letter. So you first have to insert each character one by one, and then assign a blank string for its value. And afterwards, you're going to have to, one by one, essentially have to call this get path for every single character in the letters file, one by one, return that path, and then you have to update that character's value using the result of that get path function. So we have everything inserted into binary search tree. The values will be all blank, but one by one, you just have to call get path for each character, receive that path, and then you have to call the update function and reassign that character's value with the path constructed from the get path function. So that's going to essentially, when you do that, you will essentially have every single character will be mapped to its Morse code. And then you also in main have to create a second binary search tree object, a string that maps to a character, because you want to map each Morse code to the original letter. So you have to just find a way to take your binary search tree that maps a character to string. You want to create another binary search tree that maps a string to character, which is going to be mapping the Morse code to the original letter. So I'll let you figure out how you want to create that reverse map or reverse binary search tree. Okay, so once you have that, you have to now, essentially, the next file you have to read in will be the Resident Evil 3, the original game's plot. And again, to this day, I still can't get over the fact that they messed up the original remake. I even talk about that here in this file because I have to take a shot at this because it was 2020 and, it was a miserable time. And then I was at least being hopeful they're gonna have a nice remake of the game, but no, they had to mess it up, and it's okay. But I can never get over this, so I may, in my class, mention this a few more times here and there, and I might get into a crazy rant. I don't know, but it's just is what it is. That's life, I guess. Anyway, enough of that. So basically, you want to do the following in this file. You want to one by one read in each character one at a time, and you want to output the equivalent Morse code value. The Morse code string, essentially, is the goal for this. That's going to be the first part of this input, or first part of this program. Now, you also have to be able to take the encrypted string and then be able to map that to the original Resident Evil 3 plot string. So in this case, here's your the encrypted message, and you want to reverse this into the original plot. So let's go ahead and just go over how to compile and run this, and so we can see how this actually will work. Okay, so now to compile this, well, we'll just do g++ bst.cpp and then main.cpp. Okay, now we're going to run this with ./a.out like this. Now for the input, we're not going to prompt anything because there's no point. We're just going to read in our file names. So I'm going to type in letters01.txt space. I'm going to type in re3.txt. And then I'm going to type in E for encrypt. So we're going to take the letters from letters 1. We're going to go ahead and read in these letters, create a binary search tree, construct our two binary search tree objects, our character to Morse code, our Morse code to character. And then E tells us that I want to encrypt this using the Morse code we construct using this letter ordering. And then the output will be just all of this. So essentially, I can imagine that looks like the lower capital R has this Morse code associated with it. And we use the pound symbol or hash symbol. I'm not sure what's the correct term. When I was much younger, it was called pound sign, then became the hash symbol, hashtag. I don't know what it is anymore, but it's that symbol right there. So we're going to use that as our delimiter because Morse code, we have to have some type of character that separates the Morse code because otherwise it will cause potential ambiguities. You can't tell when the next letter begins. So anyway, there's our first letter. The next letter will be E. So I'm guessing E's Morse code will be this. And we output a pound symbol after. So we output a pound symbol after every one. So all we have to do is one by one, read in the character, find, or we have to essentially call the getValue function, that letter, which then returns the value, which will be the Morse code, and it will just output that to the screen, followed by the pound symbol or hashtag. That's all you have to do for the encryption. And in fact, I also gave you a test file, which you can also, it's going to be also used in CodeGrade as well. So I gave you this file. So you just take BST, your implementation file. You can use this output morse.cpp, and you can run this, type in letters01.txt, and then it gives you For each letter, it gives you this Morse code mapping. So I gave you this file. You can use this to test out to make sure if your Morse codes are coming out correctly. So at least if it's coming out correct, then at least, um, if let's say you're having errors still, then it means your main has some issues. So at least you're trying to, potentially reduce the amount of likeliness. So we want to know for sure if our BST is correct. Okay, cool. We have that down. Then at least we don't have to, then the main has the problem. We want to, if in case our program has errors, you want to make sure we narrow down where the errors can possibly be. And I found out recently, I don't know, I think this is actually incorrectly spelled. I think it's supposed to be 2 M's, I believe, for comma, not 1 M. So I think it's spelling coma. But you know what? It works out okay, actually. I don't want to change the code grade setup and everything anymore, so I'm just going to keep it like this. But it makes sense. I mean, it is Resident Evil 3 themed. Resident Evil Requiem just came out, so, coma, infection, Resident Evil, it does make sense, actually. So in a sense, it does really fit the spirit of the Resident Evil theme. So I'm going to say, I'm going to keep it in there. So I'm not going to change that. So that is misspelled, I believe. If not, then, well, anyway, just whatever, comma. So anyway, there we are. That's that, comma symbol. That's what I meant to put there. So there we are. So that's going to be, you can of course use it to help you test out your code. So now let's go ahead and go over the case we want to encrypt or decrypt. Sorry. So this is actually the file you would get if you were to encrypt the Resident Evil 3 plot using letters 1 letter sequence. Now, this is going to be one long line because we actually encoded the end of line character into Morse code as well. So we're not gonna output a new line character in our file. It's actually one big long line, but I believe my editor just does like a word wrapping technique of some sort, but it's actually one giant line is the idea. So what we want to do is we want to decrypt this. Now to decrypt this, it would be the same as encrypt. So we would, of course, let's recompile. So bst.cpp and then main.cpp. So I'm going to put in letters01.txt and I'll put in RE3 and I believe it's called encrypted. So I'm going to try my best to make sure I spell this correctly. Encrypted 01.txt and of course D or lowercase d for decrypt. So we're going to decrypt this, and we should output the original plot of Resident Evil 3. And there we are. There's the original plot right there. It's a little bit word wrapped in my terminal, but this is the original plot, so it decrypted it essentially. So it took this and it put it back to the original text. So essentially, that's going to be the assignment. So again, so of course you got to figure out a few things how to, set up, the maps and the binary search tree objects in main accordingly. But that's basically the assignment. So hopefully this video did help you. And I guess happy coding and till next time.